Welcome to another day on the Journey Chez Chem. Please do the 2 warm-up questions to the best of your ability. Both of them are types of reactions that we will be doing tomorrow in the lab. So we need to practice them a little bit, and so do the best you can, and we'll go over them in a moment. In these reactions, what we are beginning with are always aqueous. And therefore, I know that they are also double displacements. And in this case, I am going to get lead 2 iodide and 2 sodium nitrates. Now, I need to look on my table of solubilities at the negative position. And iodides are soluble primarily, except for lead is an exception. And therefore, lead 2 iodide is my solid. And when I look at nitrates, nitrates are always soluble. They're one of the dateless dudes, those nitrates. They never combine to form a solid, and therefore it is aqueous. Now, everything that is aqueous must be separated into its ions. We have to put a coefficient of 2 in front because we have 2 sodiums on both sides. 2 sodium ions, aqueous, plus 2 iodide ions, aqueous, plus lead ions, aqueous, plus 2 nitrate ions, aqueous, and I cannot have a solid separate because it has to stay together if it's a solid. Lead 2 iodide and 2 sodium ions aqueous and 2 nitrate ions aqueous. Now, things that are identical on both sides are my spectator ions. And I see that my sodium ions and my nitrate ions are identical on both sides. Therefore, they are my spectator ions. My spectator ions are sodium and nitrate. And remember, they must have their charge or they're not ions. Then I remove the spectator ions, and what I'm left with is my net ionic equation. Now, I want to show you this reaction. I am going to take a test tube and I am going to add some sodium iodide. And you can see that my sodium iodide is a clear liquid. And I will add this clear liquid into my test tube. I love this reaction. You're going to love it just as much as I do. Yes. Now, that was the sodium iodide. So you can see that the sodium and the iodide ions are floating around that solution. Now, I am going to add only a little drop of this lead 2 nitrate. It's very incredible. So let's pay attention. Are you ready? I'm going to put 1 drop. You ready? Okay. Did you see that? That's amazing. This was a clear liquid in this dropper, and it made it yellow. That's right. It's a beautiful yellow. Isn't that beautiful? Now, if I let this settle, you can see that the particles are very fine, and they are dropping. Sometimes they become suspended in there, and it's difficult to tell what the color of the liquid is and the color of the solid. So we have to let it sit. And when we let it sit, you can see that my liquid is clear and my solid is definitely yellow. This is a very famous reaction of lead to iodide. Is very characteristically canary yellow. That's why we love it so much, because it's like a canary. And there you have that. Now, that was my question here. And you can see that floating around in the liquid are the sodium and the nitrate ions. And the lead ions that were aqueous and the two iodide ions that were aqueous formed my yellow, beautiful canary lead to iodide as my solid. And that was that reaction. I just love that reaction. And there you have it. So if you had this on the assessment, you would get 4 points for the various parts. You need to be able to do these. And I'll be right back to do number 2. In number 1, in number 2, it is always important to write my formulas correctly, and we'll be practicing this all year, so you need to figure it out. Ammonium has a +1 charge, and chromate is -2. Therefore, I need 2 ammoniums in order to get my compound to 0. Magnesium is +2, and acetate is -1. Therefore, we need 2 acetates in order to get our compound to 0. Now, these reactions are double displacements, and therefore I get magnesium chromate and ammonium acetate. And it is important for me to understand that ammonium is +1, acetate is -1. Therefore, I need a coefficient in order to get the right number of atoms. Now, everything that I began with was aqueous. And I look at my table of solubilities, which you will be given on the assessment. You don't have to memorize those things. I know that we've learned a lot, but you don't have to learn that as well. I will give it to you on the assessment. Now, I look at the negative position of chromates, and I see that chromates are mostly insoluble. Therefore, this will be my solid. And ammonium is dateless, and so is acetate. Therefore, this is my aqueous. Now, everything that's aqueous must be separated into the ions. And I have 2 ammonium ions, aqueous, plus chromate ions, aqueous, plus magnesium ions, aqueous, and 2 acetate ions, aqueous. And I get my solid, which stays together. I cannot separate a solid, but I do separate all my aqueous into their ions. And the things that are identical on both sides of the equation are my spectators. And that would be the ammonium and the acetate. Now, it is possible to have all spectators or even 2 net ionic equations, although 2 net ionic equations are a lot more difficult and we don't see them very often. But it is possible that everything could be aqueous. Therefore, my spectator ions are my ammonium and my acetate ions. And when I remove those ions, what I'm left with is my net ionic equation. So my net ionic equation is my magnesium ions, aqueous, plus my chromate ions, aqueous, forming my solid magnesium chromate. That would be my net ionic equation. And that's how you do those. And you will be required to do all of those on tomorrow's lab when you do the final write-up on that lab. Now, there's one more thing I need to tell you, and I'll be right back. The lab procedure that you've been given is very brief, and it has no data table. You will need to write out this data table. where you have 5 reactions and you will record the color of the liquid and the color of the solid. Then after that, when you are finishing this lab write-up, you will actually identify the liquid. And in the very first reaction that we had in today's warm-up, the liquid would be the sodium nitrate. And you will identify the solid, and that would be the lead 2 iodide. But you will have 5 reactions that you are doing tomorrow in the lab, and you will need this data table in order to write up the complete lab. Now, you need to make sure that you write up the lab for tomorrow. That's the only thing you need to do. And I can't wait to see you tomorrow when we can do lab together.